Hello. Today we're going to look at creating a capacitive touch interaction using Arduino, and you want to make an interactive art piece where the participant just touches something and an output happens. So in our case, we're going to touch something and turn on an LED, and I've used capacitive touch in artwork twice now. One was to touch conductive paint and make NeoPixel LEDs turn on and change color. And then the other one was whenever you touched the sensor, I use P5JS as like a visual display code-based interaction. So you could touch a sensor and actually change whatever is occurring on the monitor. You can do this with processing and probably Touch Designer too. So let's get going with, first we need something capacitive to interact with. And so this could be anything metal. You'd use silverware, found objects, which is what our experiment 1 is going to be based on. In my case, just for this demo, I'm going to use these hooks. They're technically not found objects because I did forge them a long time ago, but I did just find them in my closet, so I didn't even know I still had them. So they're kind of found objects, but for you, you'll actually go out and find some. And then also, I'll teach you how to make interactive paint using, let's see if I can get this pure graphite powder that you can get on Amazon. I've got this Liquitex acrylic medium, which is just a gel medium. It's clear, and so it's just going to keep the black of the graphite. You can also use, I use Liquitex paint, acrylic, which is acrylic paint, for all my paintings these days. And you could use white or black paint as well if you want to get gray tones, like different value, and create like an actual, black and white painting. You want to be careful with that because the more white you add, the less conductive it's going to be. So you just have to find that balance. Equal portions of this to equal portions of this. So I'm gonna do 1 teaspoon, 2 teaspoon, 3 teaspoon. When you're done with it, close that lid back up. And this is where I'm gonna just eyeball, because why not? And then stir it on up. And the minute eyeballing measurements stops working for me, I'll let you know. So far, it's not been a problem. And now we can just apply our paint to the paper or whatever you want to paint on. One thing you're going to notice is that it's dark gray. It's not exactly black. So if you want to get a more black value, then you should use black paint. So I'm going to let that dry, and I'm going to bring in this other thing that I created for an installation, which is, this is my shape of my hand, made of wood that I cut out with a jigsaw, and I just coated it with this graphite paint onto wood. And then I have this screw right here. It's just screwed into like the end of the hand. And I wrapped a wire around that, a jumper wire, and connected it to Arduino so that when you like touch the hand, it interacts. So that is one thing that you could do with this technique. Capacitive touch is used in touchscreen devices, like whenever you're touching your phone, for instance. And your body is super duper cool because it is conductive, and your fingertips hold a small amount of electrical charge. So if your body has that charge, and then your conductive material can also hold an electric charge, whenever your body comes close to or connects with this charge and like adds to it, and the Arduino is connected to that, Arduino will detect the change in the capacitance. Once Arduino detects the change, it can trigger a response based off of the way you coded it. So let's move to Arduino materials. Here I'm using an Elegoo Eleg, I don't know, Eleg Infinity Uno R3, which is the same thing as an Arduino Uno. I have my little breadboard. So in this, we're gonna need 2 resistors, and these are super tiny, so can't see that very well. But this one is a 220 kilo ohm resistor, and this one is a 1 mega ohm resistor, a 1 mega ohm resistor. So you have like spare resistors. You can go online and be like, what is my resistor? And there are things where you can like tell it the color, and it'll tell you what it is. So for capacitive touches, as long as you have at least 1 mega ohm, you'll be fine. And then you may need more depending on the project. You're probably going to want to get a wire kit for your jumper cables so that you can create like long extensions. Sorry, this isn't the best view. And then you're gonna have to get like a wire cutter with that as well. I'm just going to use jumper wires, which already have this little plastic piece on the end of it. The problem with this is that they're not super long, but they'll work for prototyping for right now. So I'm going to find a black one in here, and I'm going to attach it to the negative track on the breadboard and the G and D pin on the Arduino. Okay, after ground, we're going to go grab our 220 kilo ohm resistor, and for now I'm just going to take it and bend it like that. I like to use tweezers for this, and then also you can snip it off there, but I'm not going to do that. I'm going to connect one side to the negative track that's connected to the ground over there, and then the other side just anywhere over here like that, and then do the same thing for the second one. Like so. Just try to keep it clean. And then you, if you're going to use LEDs, you can just practice with LEDs and then change the output later. I've got a red and a yellow that I'm going to toy with. So if you remember from your fundamentals classes, if you're in my program, the long leg of the LED is the long powerful leg, which will connect to power, which means the digital pin on the Arduino circuit board, and the short leg will attach to ground or connect to ground. So this resistor is connected to ground, so we will connect this LED's short leg to the resistor. And same for this one. And then the long leg of the LED, you can just connect to whatever digital pin you want on Arduino over here. So I will be just connecting the yellow long leg to pin 13. And here with my jumper wires, if it looks like this, you can connect them to extend these guys, and just use this white one. And the red I'll attach to 12. Next up, we need to put our 1 mega resistor, mega ohm resistor on. So same thing, just put it on wherever you think is best. And here's where I think we should note that if you want to use multiple sensors, like say I want to take my hooks here, and if I touch this one, I want one light to turn on, and if I touch this one, I want the other one to turn on. If I wanted like 5 more hooks, like you're going to end up using a lot more space on this board here. So I actually suggest using a longer board, something like this, but you can always just bring another board in if you need. I'll stick with the shorty for right now. So put the one in anywhere, and put the second one on as well. This is where I really do need to start cutting my wires, so I'm going to do that. I just used scissors just now, but you should probably use a wire cutter. I'm gonna go ahead and cut my other one. We're gonna connect one side of this resistor here to digital pin 2, and you're gonna connect the other side of that same resistor to digital pin 4. Doesn't really matter which one you do. And then the second, we will do the right side will connect to pin 6, and the left side will connect to pin 8. And lastly, on this first one here, the one that's connected to, the side that's connected to digital pin 2, on the other side of the resistor, we will connect another jumper wire. And this jumper wire here is going to be connected to anything metal or our capacitive touch sensor. So technically we could just like grab it and trigger the reaction, but we don't want to just grab a wire to trigger it. We want it to be more interesting. So let's go ahead and connect our paint here. And I've got these alligator clips here, boop, boop. So I can just sort of attach the alligator clip to wherever the paint is touching, and then attach the other side to the end of the jumper wire. And so that's gonna work. And then just to show you a different option, I'll use one of my hooks as well. So with another alligator clip, I will attach that to the end of the hook. And I'll just put my hook like that. So attempting to be as clean as possible over here, but I think we're starting to get into mad scientist territory. We need to add a jumper wire to the other side of our second 1 mega resistor. So the jumper wire that is attached to pin 6 right here, we'll attach that to here. So we need just one more jumper wire, plug her in right there like so, and then attach our alligator clip to the end of that. And voila, a little bit extra over here, but I just wanted to show you a couple of different possibilities. And I mean, look at this art piece that we've already created. No, you'll have to work a lot harder than that. But that is the hardware setup. So now we should be ready to go to plug this bad boy into the computer, get into our Arduino IDE, create the code, upload the code, and touch this stuff and watch the LEDs turn on. So let's move over to the code. Okay, so I already created the code here in tinkercad.com. It's like an Arduino simulator, and it doesn't actually work for capacitive touch. You have to like use buttons and stuff instead. But I wanted to make this diagram for y'all just so it was a little bit easier to see like where the resistors and the jumper wires are being connected. So these aren't connected to anything because this is like assuming you've connected these to something metal or something capacitive. So that's just for your convenience, and I'll share it with you somehow, probably in Canvas. For those of you who are in the class, I'll put it in the description below. So I will just copy this. In Arduino, I will paste it. And so let's just go over what everything is real quick. Up top here, this little hashtag include capacitive sensor.h is adding in the capacitive sensor library. So another way of doing this is to, because I don't think you can just type it out. I think you have to go to Sketch, include library, manage libraries, and then just in filter search, just type in capacitive sensor Paul. It's capacitive sensor by Paul Badger and install. You may have to go back to Sketch and include library, and then you will see it'll show up right here, and you can just like click on that and boom, there you have it. So I'll get rid of that second one. Let's put this down a little bit. So next up here we have capacitive sensor sense1. Oh, and by the way, this code is going to be in the description below, so you can just copy and paste it over. But this is how we add an instance of the sensor to our sketch, and I'm calling it sense1 and sense2, or I could call it like painting and metal or whatever I want to call it. That's descriptive, but I'm being pretty vague right now. You said it equals to capacitive sensor from the capacitive sensor library, and then inside the parentheses we have 4 and 2. So this order here is super duper important. So one side of the resistor is going to be the transmitter and one is the receiver, and the transmitter is going to be 4. So like this first spot is for the transmitter. The second spot is going to be for the receiver. So if you recall on digital pin 2, that is on the other side of the resistor. That's where we are connecting it to the conductive object. So that's receiving the energy that we put into it, and then transmitting is the other side, the digital pin 4. So this is the same thing for the second sensor. It's connected to 6 and 8. So you just want to make sure you got that right. If you need to switch these around because you got it wrong, just make sure you keep that in mind. It took me a long time during one of my first capacitive sensing projects to figure this one out. And yeah, so don't forget that. Next, we're defining thresholds. So whenever we touch that capacitive object, we're going to get some values that we can print through the serial monitor and see what those values are. Those values are going to range, and it just depends on like your location, the pressure that you're touching with. And I'm actually just going to do one threshold right now, but actually I'll keep 2 thresholds. So this threshold is like going to mean something in our if statements down here. So basically it's going to be if threshold 1 is reached, so when we touch the object lightly, something would happen. But I'm going to change this to 1000 because if we touch it with more pressure, something else could happen. So that's sort of like the idea here. Or you could just say if it's touched at all, and like if it's reading a value past 700, then do something. So you don't need 2 thresholds, you could just work with 1. And then these are going to need to be adjusted based off of the serial readings that you have. Defining the LEDs. So 12 is the red light and 13 is the yellow light that I have. So I'm going to switch this to yellow and red. 12 and 13. Constant, so it's always going to be 13, it's always going to be 12. In void setup here, you're going to do serial.begin 9600 to start the serial communication so that you can debug and see what the heck is going on. You absolutely 100% always need this. And then we're going to set our pin mode, yellow LED and red LED. So red LED, and instead of green, I'll say yellow. You do whatever you have. Set it to output, all caps. And then in our loop, this is where we're starting to get the action going on. So this is where we actually read our sensor. So we're going to create a variable called sense1val and sense2val. And we're going to use the data type long and set it equal to sense 1, which is our sensor up top here, dot capacitive sensor, and open and close parentheses and 30. And so 30 is the amount of readings that will occur. So if you're like touching the capacitive object, it'll read 30 times, and it's samples for averaging out whatever value it is, the value of the sensor, right? So 30 is like the go-to number here, but if you go up to like, let's say 50, it's gonna be more accurate because it's gonna read 50 times and like average out those numbers and like give you a value. But the problem is it's going to take longer to read. So if you make this shorter, it'll take less time, but it'll be less accurate. So you sort of have to find a sweet spot. So 30 is sometimes the sweet spot. Here we're printing values for debugging. So we're going to print, and it says, I'm going to change this to print ln. So serial.println, quote unquote sensor 1, because we want it to be a string, and then sense1 val. I want to read whatever the heck this is, whatever the value is. And then we've got sensor 2, sense2 val. We're going to read the second sensor. Okay, so everything looks pretty good. Check threshold and control LEDs. Here, let's cover this if statement. So if sense1 val is greater than threshold 1, so threshold 1 is 700. So if this reading here is greater than 700, we're going to turn the red LED on, else turn it off or set it to low. If sense2 val is greater than 700, the threshold, we're going to turn yellow LED on, and then if it's not, we're going to turn it off. And then we've got this little delay here. Let's just go ahead and connect our USB from Arduino to our computer. Luckily I have a USB extender because my computer is on the other side of the room. And then once that's connected, you can go to select board here, or you can go to tools, board, Arduino, AVR boards, and then Arduino Uno. You just also want to always double check on the port. So I just came over here and did like this COM3 here, but I'm just double checking because I'm paranoid about it, and going to port and checking that Arduino Uno is right next to COM3, and so that's correct. And so we should be able to check our sketch and see if everything's good. It says done compiling, and there's white text, not red text, so that's good. And now let's upload. And so back over to our wild setup. Let's test it. All right, so don't start panicking if it doesn't work perfectly right away. The answer is more than likely the fact that you did something wrong with your hardware setup. So I accidentally mixed up the two resistors. I put the 220 kilo ohms here instead of the 1 mega ohm. So I had to switch this resistor with this resistor. And so now you'll see that whenever I touch my hook here, that the yellow light turns on. And whenever I touch my paint here, it's very light, but you can see that the red light turns on. So it's super light, probably just because some LEDs are kind of dying a little bit. So if I really cared, I would go ahead and switch this out to a different LED, but you can see boop, 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 boop. The yellow one is working pretty well. So threshold 1 at 700 seems to be working just fine, but you'll need to keep an eye on this value here. It's moving really quickly, but it looks like the sensors are around like, you know, 2 digits here. And then whenever I touch them, oh, it goes up to like 2,000. Hard to tell, but, and then, yeah, it's around the 2,000 area. So if I lightly touch, you can see some 1,000s in there. And then if I press really hard, it's 2,000. And from here, you can start to make some really super cool projects. So in the next video that I make, I'm going to talk a little bit about the projects that I've made using capacitive touch so far, which is only 2 projects. One's an installation and one's a wall hanging piece. So I'll talk about that. And then I really want to talk about how to embed Arduino into these installations or these pieces that you build, because I'm not like the best ever at this, but I did start somewhere and I progressed as I went. And I just want to show you, because each project that you make requires a different integration system, and I just come up with one as I go. And there's no perfect way or right way to do a thing. It's just like however you can make it happen, that's what you need to do. And so I'll just show you a couple ways that I have found to integrate it. So I'll see you in the next video.